This is our Beard-Lambert law. We use this formula to calculate absorbance. We found the molar concentration from the dilution formula that we used in the first part of the lab. The optical path length would be the length of the curvette that we use. The molar absorption is the lambda max that we found in the first part of the second part of the lab. Failing to zero the blank means that we would find the ammonia and the water in our calculations for the lambda max, so we need to zero it out just to make sure that our molecular absorption is the correct number that needs to be.
In the beginning of the video, we are moving our stock, dilutions, our blank, and the unknowns into the curvettes. We are putting it just up to the line and making sure it is not overfilled. Shown here is dilution 1. We did stock off camera. Shown here is dilution 3. We did dilution 2 off camera. Here we are adding water for our blank. Here we are adding a couple drops of ammonia.
Okay, so this is why we added the ammonia to the blank, because whenever we zero out the machine, we want to make sure that it's not picking up the ammonia and the water. We want it to only be picking up the copper amine that we added to the solution. So we have to zero everything out that isn't the copper amine. So that's why we added the ammonia to the water solution for the blank.
In these next two segments, we are moving the unknowns into the curvettes. We are still making sure not to overfill the curvettes by adding only up to the line. Now it's time to move to the spectrophotometer room. First, we open the program Scan. Now it's time to insert the blank. We are going to be wiping down two sides of the curvette and then placing those two sides towards the beam. Now we are zeroing it on the computer. Now it is time to clean and insert dilution 1. We pressed start and then it pulled up our graph. Now we find the peak of our graph, and it is the wavelength at which we can record our absorbances. We use the highest peak and smoothest point. In the first part of the video, we scan across all the wavelengths to find the point of highest absorbance, which is our lambda max. In the next part of the video, we're using the lambda max to find the absorbance of each dilution at that wavelength. Now I'm cleaning two sides of the blank. Now I open the machine, place the two clean sides towards the beam, and close the machine. Then I click Setup, enter the wavelength, and then I zeroed it. For this part of the lab, we switched to the program Simple Reads. Now I am cleaning the stock, and then I put it in and I clicked Read. These were the values we got, and now we will repeat that step for each of the curvettes we have. We only zero once. Now we are doing dilution 1. These are our values. Now we are doing dilution 2. These are our values. Dilution 3. And here are our values. This is our first unknown. And these are the values. Lastly, we do unknown solution number 2. And these are our values. Make sure to always clean up and keep your area nice and clean. And record everything. These were all of our absorbance values, and the relationship between concentration and absorbance is linear.